Assalamualaikum. Today I from a group will present our group project for ITT640 wireless network. And for the presenters for today video is me. My name is Marha Firzanah and my other two group members, which are Muhamad Hakim bin Azam and Muhamad Afif bin Abdul. For the first chapter, which is introduction. Uh, First one is company background. The company's main office is a three-story building. The project scope is to create a network diagram for each of their floors and explain it. The network diagram is necessary because it will allow network administrator and system administrator to understand network design features. The network diagram will also be documented, which explains the element used in the network diagram, the segmentation of the wireless network from the rest of the network, and the justification of for the number of access points required on each floor, as well as the explanation of framework users and wireless standard use. Alright, for the next is problem statement. The first one is limited network diagram. Because there are no remote users, the diagram will be limited to the main office building. Each floor has its own wiring closet, which is connected to the ground floor wiring closet via fiber. The second one is the wireless access point is overlap. The wireless access point in the center of the building will overlap. You need to choose unique wireless network channels for either end. Guests should have access to an additional Wi-Fi connection point in the first floor conference room. The last one, for the last one is the wireless standard should be notified. The company is separated into many departments, which are the ground levels, shipping, receiving department, manufacturing, sales department, and conference room. Meanwhile, the information technology and R&D departments are located on the first floor. Finally, the administrative and financial office are located on the second floor. Okay, for next, for group project is objective. First is design a wireless network for a small company with a three-story main office building. Second one is identify the IP address strategy and their associated subnets. And third one is identify and describe the wireless standard that play a role within your network. For last one, for chapter one is significance. The finding in this diagram may be used to develop and implement several additional features for the company's wireless local area network, WLAN, in the future, such as the ability to remotely access each other or their device on each level, with the implementation of remote users capabilities. In addition, the IP address and subnets connected with the wireless standard have also been determined. Right, that's it for me. I'm going to pass to my other colleague.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad Hakim bin Azam, and I'm going to continue for chapter 2, which is literature review. Alright, for literature review, we can see WLAN technology is the abbreviator for wireless local area network. WLAN, wireless local area network, is a network that enables device to connect and communicate wirelessly in contrast to a standard wired LAN, where device connect via Ethernet cable. WLAN device interact over Wi-Fi. For protocol IEEE 802.11, you can see there is three types of IEEE 802.11, which is the first is the X, A, B, G, I, and N. For the X, these standards improve the security at local area network by establishing an authentication framework that allow user to authenticate against a central authority like LDAP or Active Directory. For A, in the 5 GHz band, 802.11a applies to wireless local network area and enables a maximum to connect rate of 54 Mbps throughput. For B, 802.11b is a wireless local area network standard that enable a maximum to connect rate of 11 Mbps in the 2.4 GHz ISM band with fallback to 552 and 1 Mbps. In 1999, this standard was ratified. For IEEE 802.1g, in the 2.4 GHz band, an expansion to the 802.11 standard that provide for a maximum connect rates of 51 Mbps while remaining compatible with the 802.11b standard. This standard is compatible with complements of 802.11b standards. For IEEE 802.11i, for an optional, fully compatible implementation of 802.11i, this additional include enhanced encryption techniques and as well as integration of IEEE 802.11x authentication protocol as well as sophisticated encryption mechanisms such as AES, which is Advanced Encryption Standard for IEEE 802.1n. Multiple transmitter and receiver antennas are used to boost data speed and range, also known as multiple input, multiple output, or MIMO. In 2009, this standard was ratified commercially available pre-standard gear is incompatible with Bitnet Wi-Fi. For review of hardware for WLAN, there is three hardware, which is first wireless access point, router, and switch. For wireless access point, a wireless local area network, which is WLAN, is created by an access point AP. A wireless network infrastructure is incomplete without access point. They transmit a Wi-Fi signal to a defined region and are hence commonly seen in workplace and huge building. APs allow numerous devices to connect to Wi-Fi, including laptop, cell phone, and tablet. Router, a Wi-Fi access point and a network switch are commonly included in consumer Wi-Fi router, which are the two equipment required to set up a Wi-Fi network. If you connect a solo Wi-Fi access point to a solitary network switch, you may create a Wi-Fi network for all the devices connected to it that function like a Wi-Fi router. For switch, a switch is used in a wired network to connect to other device using Ethernet cable. The switch allow connected device to talk to other wireless only network. Do not use switch because device such as wireless router and adapter communicate directly with one another. Right, for chapter 3, which is WLAN design, for network requirement, the placing of an access point and access point that can accommodate a lot connectivity, an access point with a huge high-speed internet connection, the placing of an access point that can accommodate a lot of connectivity. As you can see here, the number of access point, the data rate, signal, ping round trip, at most packet loss, have a different result for every floor, but mostly have the same. The only difference is on the number of access point, which is on the ground floor. The number of access point we have is 6. First floor we have 4. Second floor we have 5. Right? For the data rate, all the same, which is 60 Mbps. Signal strength at least negative 70.0 dBm. Ping round trip time at most 150.0 millisecond. And the last one is packet loss at most is 5.0%. Right. For the capacity, for the ground floor, number of device, which is laptop, which is 25, smartphone 33, and tablet 4. For the first floor, the number of device, which is 9, smartphone 11, tablet 2. Second floor, number of device or laptop, which is 27, smartphone 21, and tablet is 7 for the capacity. And as you can see here, this is the coverage area for every floor. As you can see here, the coverage area for ground floor is 5231.6 for the first floor, which is 2761.2, and for the second floor is 4243.2. Alright, for the floor map, as you can see here, for the ground floor we have the coverage around 6 router, sorry, 6, yes, 6 access point, like been mentioned before. 1, 2, 3, 4, 5, 6 for the ground floor, and the first floor, which is we have 4, 1, 2, 3, 4. That will cover all the coverage. And for the second floor, we have 5 router, which is 1, 2, 3, 4, 5. It also cover for all coverage. For the access point information, as you can see here, we have mostly have the same information, but for the SSID and the radio channel have a bit different, which is, for first of all, the same is type, which is Cisco AeroNet, SSID ground floor AP6, radio on channel 1, maximum client is 5, speed 120 Mbps, standard we use 802.11 A, B or G, authentication security AS4WPA2, and then 802.1 times radius. For software, we use Cisco Unified Wireless Network Software and Cisco Mobility. Frequency support, which is 254 GHz and 5 GHz, and range around 90 meters. IP address for the ground floor is 192.168.10.0/24. For the guest AP also, not much change. Just change on the ground floor AP, which is 1, radio on channel is 6, and then for the IP address, which is 192.168.100.0/24. Same goes to the first floor and second floor. First floor have the same amount like the guest, which is 6, and the SSID for ground floor AP is 4. And for the IP address for first floor AP is 192.168.20.0/24. Alright, for second floor AP, the SSID is ground floor AP 5, and the radio channel is the most, which is 11. And then the IP address for this one is 192.168.2.0.0/24. And this is the network diagram. You can see it cover all, which is this is the first floor, second floor, and this is the ground floor. Alright, next we go to chapter 4.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhamad Afif bin Abdul Qadir. So today I will show and demonstrate the network simulation in Packet Tracer. So as you can see here, this is our logical network diagram. So it have several devices that we use, which are router, switch, wireless access point, and the end device such as laptop, PC, and a smartphone. So we have ground floor, first floor, and second floor. So for now, I will test the connectivity between the network in different floor. So we go through on ground floor. So I will choose the laptop one with the IP address 192.168.1.5. Okay, and then click command prompt. So I will try to pin from laptop in ground floor to the laptop in the ground floor. So for example, pin 192.168.1.6. Okay, so this is the result. So there are 0% packet loss. So next I will try to ping from laptop at ground floor to laptop uh, at first floor. Ping 192.168.2.5. Okay, so the result is good, and you can see there is zero packet loss. And now we try to ping from ground floor to the second floor, 192.168.3.5. So the result is same, which is 0% of packet loss. So next we go to the first floor. For now, I will try to ping from the laptop first floor to the first floor. Pin 192.168.2.7 for the PC 2. Okay, the result is good, and it shows the zero packet loss. So next I will try to ping from first floor to the ground floor. For example, 192.168.1.5. So the result is same, which is 0% of packet loss. So next I will try to ping from first floor to second floor, which is the IP of the laptop at the second floor is 192.168.3.5, for example. Okay, the result shows there is zero packet loss. Okay, so next we go to the second floor. So for example, I will try to open the laptop 0 with IP 192.168.3.5. Click and then go to the command prompt. So now I will try to ping from the second floor to second floor. For example, I will try to ping 192.168.3.9. Okay, so the result show the zero packet loss. Okay, so now I will try to ping from second floor to the ground floor. For example, 192.168.1.5. Okay, the result is show 0% of packet loss. So lastly, I will try to ping from second floor to first floor with the IP address of the laptop is 192.168.2.5. Okay, the result shows 0% of packet loss. So there is the big testing for different floor. So now I will show the result in the table. So here this is the table of network performance of simulated network. So from this network performance testing, we can get the average latency, jitter, and the packet loss in the percentage. So for the first experiment, which is ground floor to ground floor, the latency is 90 millisecond, the jitter is 23.5 millisecond, and the 0% of packet loss. The second experiment, ground floor to first floor, the latency is 32 millisecond, and the jitter is 22.3 millisecond, and 0% of packet loss. Okay, next experiment, ground floor to second floor. So the latency is 40 millisecond, and the jitter is 30.1 millisecond, and the uh, packet loss is 0%. Uh, Next is first floor to first floor. The latency is 53 millisecond, and the jitter is 40.7 millisecond, and 0% of packet loss. Next, first floor to ground floor, the latency is 41 millisecond. The jitter is 37.7 millisecond, and 0% packet loss. Next, first floor to second floor, so the latency is 51 millisecond, and the jitter is 90.1 millisecond, and the packet loss is 0%. Okay, we go through to the second floor to second floor. The latency is 49 millisecond, and the jitter is 70.2 millisecond, and 0% of packet loss. Next, second floor to ground floor, the latency is 48 millisecond. The jitter is 23.3 millisecond, and 0% of packet loss. And the second floor to first floor, we got the latency 38 millisecond, and the jitter is 22.8 millisecond, and 0% of packet loss. So that's all from me. Thank you.